Welcome to my 90-day SAT prep series. Today is day 85 of 90. So in today's video, the first thing that you're going to end up doing is you're going to be taking the math no calculator section of SAT practice test 1, treating it like you were taking the real SAT on test day, right? So you want to go through, use the pacing that I've recommended as far as the order of questions that you want to do. Also use the tips and tricks that I've taught you in order to go through the problems as efficiently as you can. The reason I chose SAT practice test 1 for the one that you're going to do today on day 85, which keep in mind is really close to your SAT test date. The reason why I chose SAT practice test 1 is because it has a lot of those tips and tricks that you want to make sure you're looking for on the SAT. So make sure you pay close attention to those and look for the most efficient way to answer the questions. So try to treat this like you were taking a real SAT math no calculator test, okay? The reason why we can do the math no calculator section in the full amount of time and treat it like the real thing this close to the SAT is because it's only 25 minutes. So it's not going to tax you too much, whereas if we were to try to do a reading section this close to the SAT, it'd be really mentally taxing, which is why we can do the math no calculator section and treat it like the real thing, but we can't really do the reading section. But that's on another note. So today, that's what you're going to want to do first, okay? After that, you don't have to check your answers on your own because I'm going to then go through and I'm going to complete SAT practice test 1's math no calculator section in 10 minutes, right? So I'll answer all the questions in 10 minutes. Keep in mind, I'll be putting in that video which I made before I started this series, so you're not going to see me follow that same order of questions that I recommend that you take, but that's not a big deal since you're really just going to be looking to make sure you're solving these questions as efficiently as possible and using those tips and tricks I'll show you in this video and that you've also seen before. So pay attention to how I'm getting to my answer efficiently, right? Pay attention to that. Also, pay attention to obviously how you did in your pacing, okay? So if you got your pacing really good, you answered all your questions in 15 to 17 minutes, then that's really, really good. Make sure that you go back, check your work with those 8 minutes, kind of try to simulate the real thing. But then when I go through, pay attention to how I'm getting to that correct answer as efficiently as possible. After that, that's going to take us bring us to right around 38 minutes in the video. So then at that point, we're going to go review formulas on the SAT math section reference sheet. So I talked in one of my tip videos, which I believe I included in this 90-day SAT prep series, about how you want to memorize all of those equations on the SAT math reference sheet, right? So that's going to be that part that's on like page 1 of the math no calculator test and page 1 of the math with calculator test, where it has those equations that it gives you that you can refer to as you go through your test. Now, the reason we're going to review those formulas, even though they're given to us on the SAT math section, is because we want to know them so we don't have to flip back and forth between pages and waste time. So after we go through this, we're going to be reviewing those formulas. All right, so with that, I'll go ahead and give you 25 minutes to complete SAT practice test 1's math and no calculator section. You can find the link in the description. So I'll give you about 10 seconds to pull that up and we're going to get started here in about 5 seconds. So as you go through, look for the most efficient way to complete it. Remember to follow the pacing that I've outlined, follow that order of questions, and with that, your time starts now. All right, your time is now up for the math no calculator section of SAT practice test 1. At this point, I will go through and play the video where I go through practice test 1's math no calculator section in 10 minutes. Pay attention to how I'm getting to my answer efficiently. Pay attention to the tips and tricks and strategies that I use for each question. Also, just understand that I don't follow that same order of questions I recommend you do. That's just because I'm pulling this video from one that I made before this 90-day course, in which I was just kind of showing people how to look at each question individually efficiently. So I wasn't really focused on teaching question order in this video, but nonetheless, it'll be helpful since you already know question order, and I'm just kind of giving you that disclaimer going into it. So make sure when you do take your SAT Math No Calculator section, you follow that question order that I've taught before. All right, if x minus 3 equals k and k equals 3, what is the value of x? Well, I'm substituting 3 in for k. I'm going to multiply each side by 3 so I can get x without a denominator. 3 times 3 will give me 9, so now I have 9 equals x minus 1. I'll add 1 to each side. 9 plus 1 gives me 10 equals x. So my answer is going to be D. Question 2. For I equals the square root of negative 1, what's the sum of 7 plus 3i plus negative 8 plus 9i? Well, 3i plus 9i, that's going to give me 12i. And then 7 minus 8 is going to give me negative 1. So I have negative 1 plus 12i. That's going to be answer A. Question 3. On Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? Where their total is going to be Armand, he spent 5 hours sending text messages at a rate of M, plus the 4 hours Tyrone spent sending messages at a rate of P. So their total together will be 5M plus 4P, which is answer choice C. Question 4. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that needs repairs. The number of phones she has left to fix at the end of the day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value 108? Well, if she works 0 days, she still has 108 phones left to fix. So that means that she starts each week with 108 phones to fix, which means the answer is going to be B. All right, question 5. Which of the following is equivalent to the expression above? Well, I'm going to go ahead and find my values that are like terms, and I'm going to go ahead and simplify. So I have x squared y minus negative x squared y. Minus a negative means I'm adding, so I'm going to have 2x squared y, which means I can get rid of a and b. Next, I look for my term that is different in these two answers here. I see it's y squared, so I'm going to have my negative 3y squared minus negative 3y squared. Minus a negative gives me plus positive, so I have plus 3y squared. That means that's going to give me 0, which means answer choice D is incorrect, and C will be my answer. Question 6. A pediatrician uses the model above to estimate the height of a boy in inches in terms of the boy's age A in years between the ages 2 and 5. Based on the model, what's the estimated increase in inches of the boy's height each year? Well, if his age goes up 1, that means that he aged 1 year, and his height went up by 3 inches, so our answer is going to be A. All right, question 7. The formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest, which the following gives P in terms of M, R, and N. Well, here's the thing. I see that I have P on this side. If I want to get rid of all of this and put it on the other side, I multiply by the reciprocal, which means what's in my denominator on the right side goes in my numerator on the left, and what was in my numerator on my left side, or on my right side, goes in my denominator on my left side. So those two switch spots. The answer choice for that is going to be answer choice B. All right, now I can go ahead and move on. We've got question 8. If A over B equals 2, what's the value of 4B over A? Well, if A over B equals 2, that means A is 2 and B is 1. Now I go ahead and substitute those values in. If A is 2, that means I have a 2 in my denominator. If B is 1, then I have 4 over 2, which is equal to 2. So my answer is going to be C. All right, question 9. What is the solution xy to the system of equations above? All right, when I see it's in a column like this, I want to figure out a way to get rid of one variable. I see I have 4y and 2y, so if I multiply my bottom equation by 2 and then subtract, I'll have 4y minus 4y, which will get me just my x's and then a number I can set it to solve for x. So I have 4y minus 2 times 2y, that gets rid of my y's. Now I have 3x minus negative x, minus 2x, minus negative 2x. So 3x minus negative 2x is going to give me 5x, because it's subtracting a negative, which means it's adding a positive. And that's going to equal negative 23 minus 2 times negative 19. 2 times negative 19 is negative 38, but it's minus negative 38, so we're adding 38. Negative 23 plus 38 is going to give me 15. I divide each side by 5, and I get x equals 3. Only answer choice with x equals 3 is B, so B is going to be my answer. Question 10. For the function g defined above, a is a constant and g of 4 equals 8. What's the value of g of negative 4? Well, if I look, x is only inputted right here, right where a x squared. So since x only goes in one place and it's squared, 4 squared equals 16, and so does negative 4 squared. So they're both going to equal 8, so my answer is going to be A. All right, question 11. In the equation above, B and C represent the price per pound in dollars of beef and chicken respectively, X weeks after July 1 during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? That means I'm setting my two equations equal to each other. So I'm going to go ahead and I'm going to subtract 1.75 from each side. 2.35 minus 1.75 is going to give me 0.6, and then I'll subtract my 0.25x from each side. I do that, I get 0.4x minus 2.5x, and that's, or minus 0.25x, that's going to give me 0.15x. I divide each side by 0.15, and that's going to give me x equals 4. I plug 4 in then for x. I'll plug it in right here. 0.25 times 4 gives me 1, so I have 1 plus 2.35, which will give me 3.35, so my answer there is going to be D. Question 12, a line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lies on the line? Well, the point is going to have to be equivalent in a ratio to 1/7, right? Or I'm sorry, yes, to 1/7, right? So if we look at our answer choices, right, we have to have a answer choice that is equivalent in the ratio of 1/7, right? So we have, if we look at our answer choices, we've got D, 14 and 2, right? That's going to give us that 2 as our y, which is our rise, over our run of 14, which is equal to 1/7. That's our slope, because our y-intercept here is 0, so that will be our correct answer. All right, now we've got question 13. If x is greater than 3, which of the following is equivalent to this equation? First thing I'm going to do is I'm going to get a common denominator in this set of equations here. So I'm going to multiply this side here by x plus 3, and this side here by x plus 2, and that'll all be over x plus 2 times x plus 3 in each side, right? Okay, so now that I do that, I'm going to go ahead and add my terms, right? So now I'm going to get x plus x, that's going to give me 2x, and then 3 plus 2, 2x plus 5, right? And this is all 1 is over this, right? And this, in our denominator right here, then we're going to have our x squared plus 5x plus 6. All right, what's this going to equate to? We're going to do 1 over 1, multiply it by our reciprocal of our number in our denominator here. That's going to be x squared plus 5x plus 6 all over 2x plus 5. So we know that this right here is going to be our answer, and that's answer choice B. All right, question 14. If 3x minus y equals 12, what's the value of 8x divided by 2y? Well, 8x is equivalent to 2 to the power of 3x, because 8 equals 2 to the power of 3. That's going to be over 2y. We know that since we have the same base, that 2 to the power of 3x minus y is equivalent to that, right, this equation here. And we know 3x minus y is equal to 12, so that means we're going to have 2 to the 12th, which is answer choice A. All right, question 15. If ax plus b plus 2 times bx plus 7 equals this equation for all values of x and a plus b equals 8, what are two possible values for c? All right, well, I know that a times b has to equal 15 because I have this 15x squared, and I know that a gets multiplied by b to get me abx squared. X squareds cancel, I get ab equals 15, and I know a plus b equals 8, so two obvious terms that will come up to mind. It's going to be a equals 3, and then b equals 5. They equal 15 when they're multiplied, and they add to 8. All right, so now I'm asked for the values of c. All right, well, let's just go ahead and substitute in. So we have 3 then times that 7. 3x times 7 is going to give me 21x. And then we're going to have that plus our b, 5 times 2, which is 10. And that'll get me 31, which means there's only one answer with 31, and that's going to be D. So D will be my answer there. All right, question 16. If t is greater than 0 and t squared minus 4 equals 0, what's the value of t? I add 4 to each side, and now I get t squared equals 4. We're told t has to be positive, so it can't be negative 2. When we root each side, we're going to get t equals 2, so my answer is going to be 2. All right, 17. All right, so we've got a bunch of lengths, and we're asked to solve for x. So we've got 800 feet, it says is CD, and then it says that BD is 700 feet, and it says that EB is 1400 feet. All right, right off the bat, I know these angles are the same, so I know if I'm going from B to E, that's similar to that length from B to D. So if I know I'm doubling going from 700 to 1400, and I also know that D to C is similar to A to E, right? Those are the two similar side lengths. I have to multiply that 800 by 2, and that gives me 1600 for x. All right, now I move on to 18. I've got these two equations. What's the value of x? All right, first thing I'm going to do is I'm actually going to go ahead and I'm going to subtract x, or I'm going to subtract my bottom equation from my top, get rid of x, solve for y, plug back in, and then solve for x. I do that, I get y minus 2y, that's going to give me negative y, and then I got negative 9 minus negative 25, that gives me 25 minus 9, that's 16. That means that y then has to equal negative 16. I plug in negative 16. Now I'm going to add 16 to each side, right? So I do that to give me just x. and that gives me x equals 7. So my answer is going to be 7 for 18. Question 19, in a right triangle, one angle measures x, where sine of x equals 4/5. What is cosine 90 minus x? I'll show you real quick. If this angle is x, 90 minus x is going to be that angle here. So if x has a sine of 4/5, opposite over hypotenuse, is going to be 4/5. What is the cosine 90 minus x? That's also going to be 4/5. All right, question 20, if a equals 5 root 2 and 2a equals square root 2x, what's the value of x? All right, well, we'll go 2 times a. 2 times a is going to give us 10 root 2 equals root 2x. I go ahead and square each side. 10 squared is 100. Root 2 squared is times 2, and that's going to give me 2x. So now I have 200 equals 2x. I divide each side by 2, and I will get x equals 100. So my answer is going to be 100. So hopefully that was helpful. Now let's go ahead and go through a review of the equations that we have for reference on the SAT. So keep in mind, obviously all these equations will be given to you, but it helps to have them memorized and understand them going into test day. So let's go ahead and just start. We'll just work left to right and then up to down. Okay, so we'll go left, right, and then we'll go to that second row. So first thing we're dealing with is circles. We know the area of a circle is going to be pi times our radius squared. We see we have our radius right there. Now we know the circumference of a circle is going to be 2 times pi times our radius, which we know is equal to 2 times our diameter. All right, moving on, we've got a rectangle. We know the area of a rectangle is its length times width. Now the perimeter of a rectangle, which we'll call P, that's going to equal 2 times its length plus 2 times its width, right? Or its length plus its length plus its width plus its width, okay? Now moving on, we have a triangle right here. Okay, now in this case, this triangle is not a right triangle. Now we know the area of a triangle is half of its base times its height, right? So in this case, we see that our height isn't a leg, so we'd have to solve for our height by splitting up this base right here, and then using that Pythagorean theorem to solve for the height if we weren't given h. All right, next up, if we did have a right triangle, for example, right here, right, let's say we had a right triangle, and we needed to solve for its area, keep in mind that we could use the height right here, the base right here, do 1/2 base times height like that. Okay, now right triangle, we also need to know the Pythagorean theorem. So the Pythagorean theorem is going to be a squared plus b squared equals c squared. Obviously, c is going to be your hypotenuse, a and b are going to be your 2 leg lengths. Keep in mind that's a right triangle. Okay, so that's a big thing you need to know there. Another thing here is that you should understand that you have 3, 4, 5 triangles, right? So our hypotenuse could be 5. We know that then 5 squared is going to equal 3 squared plus 4 squared, right? So just keep in mind, if you see you have a 5 as your hypotenuse, and you see you have a 3 as one of your legs, then you know that your other leg will have to be 4. Or if you see you have a 4 as one of your legs, then you know your other leg would have to be 3. Okay, so that's a 3, 4, 5 triangle. Another one that you should know is the 5, 12, and 13 triangle. So let's go ahead and draw that here. You would have a 5 here, you would have a 12 here, and you would have a 13 here. Okay, that's another common right triangle that you should know. All right, special right triangles. So special right triangles is another thing that you should have memorized going into the SAT. So let's say, for example, that we have, we'll do the 60, 30, 90 triangle first. So keep in mind, these are obviously both going to be right triangles, the difference being one has 45-degree angles, the other has a 60 and a 30. So if we have a hypotenuse, let's say our hypotenuse is 10, right? So 10 is equal to that 2x. Well, then what we know is we know that our side that goes across from that 30 degrees is going to be 5, because it's going to be half of that hypotenuse. And we know also that that side that goes across from that 60 degrees would then be 5 times root 3, right? It's going to be whatever that small side is times the square root of 3. Okay, so that's the big thing with those 60, 30, 90 triangles. All right, next up, we've got our 45, 45 triangles. Or 45, 45, 90 special right triangles. All that this means is that you're going to have some number as your leg, right? And your hypotenuse is just going to be that leg times the square root of 2. So what if we wanted to solve for s, right? Let's say that our hypotenuse was equal to, let's just go ahead and say 5 times the square root of 2, right? Well, then what we could do to solve for s is we know that s then would be 5, right? Since our hypotenuse is going to be s times the square root of 2. Now, what if our hypotenuse just equaled 5? Then what would s equal? Well, then s would equal 5 divided by the square root of 2. All right, so now let's go ahead and move on to our next shape that we have to deal with these reference formulas. So we have a volume formula, where our volume is equal to our length times our width times our height, right? Obviously, this is going to be for a box like this. We have our length times our width times our height. That's going to give us our volume. Now, what about the volume of a sort of a rectangle right here, right? I'm sorry, not a rectangle. What am I saying? The volume of a cylinder. Okay, the volume of a cylinder is going to be pi r squared times our height. Okay, so keep in mind pi r squared will give us the area, right, of this part here, and then we just multiply that area by that height going down or up. Okay, so that's the formula for the volume of a cylinder. Now what about the volume of a sphere? The volume of a sphere, pay attention here. The volume of a sphere is going to be pi r to the third power. You got to pay attention to the fact that it's r to the third power there. That's something that could trip people up because they might just think pi r squared. Well, when you're doing volume of a sphere, it's going to be pi r cubed times 4/3. All right, next up, we've got a cone, right? With a cone, our volume formula is going to be that 1/3 times pi r squared now. Keep in mind, it's pi r squared now, times our height. So you just do the same equation as you do for a cylinder, but you multiply it by 1/3. So that's how you do a cone. Now, what about with a pyramid like this, right? And with a pyramid like this, what it's going to be is it's going to be that same formula as for that box, except times 1/3, right? So you're going to have length times width times height. Keep in mind that that height, you see it's right here going up. You have your length times your width times your height. Now also keep in mind that length going up there, if we were to draw it like a box, we see it'd be that same length going that way, right? So if we had a length, we'll say it's right here. Okay, we see that that height is going to be the same, right? Same height. All right, so we know that's going to be 1/3 length times width times height is going to be our volume of a pyramid like that. All right, what else should you know? Well, you should know the number of degrees of an arc. Okay, so the number of degrees of an arc in a circle is going to be 360. Okay, so that's key. So if you have a semicircle, it would be 180 over 360 degrees, right? Semicircle is going to have 180 degrees, and we know a full circle would have that 360 degrees. Okay, the number of radians of arc in a circle is 2 pi. So that means that 360 degrees is equal to 2 pi, thus 180 degrees is equal to pi radians, okay? That's a key relationship you need to know. 180 degrees is equal to pi radians. Okay, so if we're going to draw a semicircle, that would have an angle of pi radians, and a full circle would have an angle of 2 pi radians. I'll draw it right here, 2 pi radians. All right, next up we need to know the sum of the measures of degrees of the angles in a triangle is 180. So let's just go ahead and say that we had an equilateral triangle where all sides are the same. They would have 60 degrees here, 60 degrees here, and 60 degrees here. Another thing that you should know is an isosceles triangle. An isosceles triangle means that your two side lengths are going to be the same, right? So you're going to have these two side lengths will be the same, and then you have your hypotenuse right here, right? That would be an isosceles triangle. Now, another thing to keep in mind with an isosceles triangle, and I'll quick show this as well. Right, we have our isosceles triangle, we have these two sides are going to be the same lengths. One thing to keep in mind then is that these two angles would be the same. Okay, that's another thing to keep in mind. Now, the sum of all the degrees of the angles in a triangle is going to be 180. So, let's say that we had a triangle that was, we'll say it's a right triangle. We've got 90 degrees here. Let's say that we had 50 degrees right here. We know that we would have to have a 40-degree angle right there. So, if you have a right triangle, what you know then is that the other two angles, they're going to have to add to 90, since you know 180 minus this 90 leaves you with 90. All right, so that pretty much covers the review of the formulas on the reference sheet for the math and no calculator and the math with calculator sections. Hopefully this was a helpful review. If you already understand this and have it memorized, that is perfect. That's what you want to have going into the SAT. So with that, thank you for watching today's video. As always, make sure to like, subscribe, and share. Any private SAT tutoring I'm doing, private college admissions consulting, private college essay proofreading I'm doing will be linked in the description, as well as a donation link if you would like to donate. These videos do take a lot of time and effort. So as always, thank you for watching and make sure to have a great day.